All right, welcome to 9.2 day 2. This is all about axis of symmetry and zeros again, except from an equation. So pause the video. I'm going to give you a couple minutes to get to work on the warm-up. It was just like your exit slip yesterday. All right, start the video, hopefully. We are going to look at the vertex of this equation. Okay, so the vertex of this equation, remember we always do our x-coordinate first, so we go over -4, and I go down 1, so my vertex is -4, -1. All right, now we're going to look at the max or min, and remember that vertex is our special point. It helps us get everything we need to know almost. Right, so the maximum or the minimum, if it's pointing upwards, it's going to be a minimum. And the only part we care about for the minimum value is that the y minimum value is -1. And notice we get that from our vertex, right? You should all have gotten the domain correct, and you can do that a number of ways. The first way would just be write the R symbol, the all real number symbol. You can also write negative infinity is less than or equal to x less than or equal to positive infinity. And lastly, the range, remember, since it's a minimum, I start my range with y every time. Since it's a minimum, all my values are going to be getting bigger than that minimum, so y has to be greater than -1, my minimum value. And this is what we learned yesterday from the graph. We have our zeros, which is where it crosses the x-axis. And we always write them as ordered pairs. And it's called a zero because it makes the y-coordinate 0. So it looks like our first one is -6, 0. Our second one is -2, 0. And I think the hardest thing that many of you may have picked up on yesterday was the axis of symmetry. And I think I yelled at you how many times, how do we start the axis of symmetry? And it's always a vertical line, so it will be an x equals line. We can do it one of two ways. We can look and see that our vertex here is at -4, -1. So I look back at my vertex, and we learned yesterday that the axis of symmetry must always go through my vertex at x equals -4. I could also take my zeros, -6 and -2, and average them together, and I would still get x equals -4. Okay, so that axis of symmetry is that vertical line that divides this parabola into two symmetrical parts. So I hope that most of you did your homework. We'll check your answers tomorrow. They're right here, but we'll check them tomorrow. So in your notebooks, you should be writing lesson 9.2, day 2, right? And your goal is to find the vertex and axis of symmetry using the equation. All right, so recall yesterday we learned about axis of symmetry and vertex and zeros from a graph. Now we're going to be able to use an equation to find the zeros, axis of symmetry, and vertex. Okay, so recall from yesterday, 0 of a function is the x value that makes the function equal to 0. We learned graphically it's where it crosses the x-axis. And the axis of symmetry is the vertical line that divides the parabola into two mirror images or symmetrical parts. So remember, that is always an x equals line. We always got to find that value, and it must always go through the vertex. All right, so let's get started with our first bit of notes. Generally speaking, to find the axis of symmetry, there's going to be a formula. Remember, we learned that a quadratic equation is in the form ax squared plus bx plus c. Right? So our formula to find the axis of symmetry is going to be this thing that's -b over 2a, where b is always my middle value. And a, we learned a while ago, is the number in front of x squared. So I would take those values, make it -b over 2 times my a value. So let's look over here at this example. My a value is 2. My a value is 2, and my b value is 4. So I go down to the equation. I would write -b, which is 4, over 2 times my a value, which is 2. And I skipped a step here, so it does equal -1, but on the top I would get a -4, and 2 times 2 is 4. So in the end, I end up with -1. Okay, so it tells at the bottom the axis of symmetry is -1. In other words, we should write that it's x equals -1. All right? So let's start off with 4 examples, just finding the axis of symmetry. I'm going to do the first 2 and let you try the next 2. So recall that the axis of symmetry is -b over 2a. My a value is going to be 1. My b value is 4. So I'm going to write negative my b value of 4 over 2 times a, which I got to be 1. Leaves me with negative 4 over 2. I get negative 2, and recall I always write my axis of symmetry with an x equals negative 2. Right, now later on we're going to use that to finish finding the vertex, but right now we're just doing our axis of symmetry. So always start with negative b over 2a. My b value is negative 18. My a value is 3. So I get negative, my b value, recall, was negative 18, so I'm going to put that inside parentheses because the equation itself has a negative, all over 2 times my a value of 3. I hope you all are saying 2 negatives is going to turn into a positive 18. 2 times 3 is 6, so in the end I get 3. Now my answer is not going to be written 3. Remember, the axis of symmetry is always the line x equals 3. All right, before we move on to the next slide, let's tie this back to what we learned yesterday. So I've already done all of these problems. Now I pulled up 2 graphs. This one goes to this first equation, y equals x squared plus 4x minus 7. And let's just verify yesterday we were looking to find that vertex, which is right here. And notice that if I draw a vertical line at negative 2, that looks like it's the axis of symmetry. So that's what we did yesterday. Okay, today we're using the equation. So same thing with the second equation. I've graphed the second equation, and we found that the axis of symmetry is at x equals 3. So let's check. If I go to x equals 3 and draw my line in, does that cut the parabola into 2 symmetrical parts? It does. Okay. So the idea is we're going from the graph now to looking at the equation. But notice that it still all ties back to that graph. Pause the video. See if you can try the next 2 on your own. Okay, I hope you've gotten a chance to try these on your own. I'm going to show you how to finish them off. Check your answers. So again, I always want you for these first couple to write down negative b over 2a because that's the equation we're working with. That gets us the axis of symmetry. My b value in this case is positive 3. My a value is positive 2. So my equation starts off with a negative. My b value is 3. My a value, it's 2 times my a value of 2. So I get negative 3, 2 times 2 is 4. Now that's a fraction, so I'm just going to leave it as a fraction, and so I write my axis of symmetry as negative 3/4. Okay, and we have one more left. Again, for these first, I want you to write out negative b over 2a for each one so you get that in your head. My b value in this case, whenever there's nothing there, remember there's a 1. So that's my b value. My a value in this case is the negative 1. It's negative 3. So I have a negative in my equation, negative b, which is positive 1, over 2 times my a value of negative 3. Leaves me with negative 1 on top, and 2 times negative 3 is negative 6. 2 negatives divided turns into positive 1/6. Now we don't leave our answer like that. We always write axis of symmetry as x equals 1/6. Now yesterday, if we had a graph, we wouldn't be able to tell that the axis of symmetry is at 1/6. So looking at this equation now, it helps us. So now we're going to take that one step further, and we're going to find the vertex from the equation. It takes 2 more steps. So far we've done step 1, find the axis of symmetry using negative b over 2a. We've checked that off our list. We know how to do that, right? The second step I need you to write down is substitute your answer in for x, so whatever you get for negative b over 2a, into your equation, and you'll get a y value out. Well, if I have an x and a y, that creates my ordered pair, and that's going to give me my vertex. Okay? So take a second and get these down. If you need the video paused, go ahead. All right, so here's our first example. Now, we could find the axis of symmetry from this before, but now we're going to take that one step further and find the vertex. So first step, we've already done that. Use the formula to find the axis of symmetry. So my a value is negative 3. My b value is positive 6. So I'm going to plug it into the formula negative b over 2a. Negative b, which is 6, over 2 times negative 3, which is my a value. So we have negative 6 over 2 times 3 is negative 6. 2 negatives turn into positive. I get positive 1. That is my x coordinate. So I get x equals positive 1. So the next step says the x-coordinate of the vertex is 1. Next, I need to find the corresponding y value using substitution. So my original equation was through negative 3x squared plus 6x minus 7. I'm going to plug 1 in for x. Okay, so negative 3 times 1 squared, I get negative 3. 1 squared is 1. 6 times 1, 6. So if I simplify that, I get negative 3 plus 6 minus 7. In the end, I get negative 10 plus 6, which leaves me with negative 4. So the y-coordinate of my vertex is y equals negative 4. The last step is to put those together into my vertex. So my final vertex is negative 1, negative 4. Okay, so we've added 2 steps now. Alright, so here's our second example. I want you to pause the video and try it on your own. So our equation is y equals x squared, subtract 4x, subtract 10. Alright, I hope you got a chance to get this one started. So step 1, find our axis of symmetry. I'm going to check out my b value. Be careful with this b value. It's a negative 4. Remember, if there's nothing in front of the x squared, there's really 1, so that's my a value. So my equation is negative b. Well, since my b value is negative, I'm going to get 2 negatives over 2 times my a value, 1. 2 negatives turns into a positive, so I get 4 over 2, and that's going to result in 2. So remember, when I find the axis of symmetry, it's an x equals, so my x-coordinate of my vertex must be x equals 2. Next step, I go back to my original equation, x squared minus 4x minus 10, and I'm going to substitute what in for x? Well, I hope you're saying substituting 2 in for x. So 2 squared is 4. 4 times 1 is 4. 4 times 2 is 8. Subtract 10. 4 subtract 8 leaves me with negative 4. Subtract another negative 10 leaves me with negative 14. So the y-coordinate of my vertex is negative 14. Right, so I'm going to erase that and write that in the correct color. Y equals negative 14. So in the end, when I go to write my vertex, it's going to be an ordered pair. I combine my x-coordinate of 2, my y-coordinate of negative 14. And remember when we talked about transformations, we called that h and k. Okay, so the vertex often we're going to refer to as h comma k, and we'll get to that later when we start transforming these. Remember, the h controlled left and right and the k controlled up and down. So this vertex has gone to the right 2 and then down 14. You have 2 more examples on your sheet. Now I really want you to pause the video, look back at your steps, and see if you can finish these ones on your own to find the whole vertex, not just the axis of symmetry, but the whole vertex. Right, this first one's a little tough because it has a fraction in it. So I will always get into the habit of writing down x equals negative b over 2a. My b value is 2, so I'm going to write negative 2. My a value is a little tricky. It's 1/2, so 2 times a half. 2 times a half, those 2's are going to cancel, so I'm just left with 1. So my axis of symmetry is x equals 2. That was step 1. Step 2 on the previous slide was then go back up to your original equation, y equals 1/2 x squared plus 2x, and I'm going to substitute in for x. So I get y equals 1/2 times 2 squared plus 2 times 2. So I replaced x with 2. Now I have to do my exponents first, so 2 squared is 4. 2 times 2 is 4. Half of 4, don't think of it like it's a fraction and it's difficult. Think half of 4, which is 2, plus 4 leaves me with y equaling 6. That was step 2. And step 3 is finally write your vertex. I combine step 1 and step 2's answer, so my x-coordinate is 2. My y-coordinate is 6, so my vertex is 2, 6. All right, if you need more time to try the second one, go ahead and pause the video. All right, now we're going to run through the second one. I hope you've gotten one of these. So step 1 is to always use that equation to find the axis of symmetry, negative b over 2a. Right, my b value is positive 6. Careful with this a value, it's negative 1. Right? So I get negative b, which b is 6, over 2 times my a value of negative 1. Negative 6 over negative 2, 2 negatives divided, make it a positive 3. So that's my step 1. I know my axis of symmetry is x equals 3. Step 2 is now go back to your equation and plug it in. So I'm going to take my original equation, and I'm going to substitute 3 in for x. So I get a negative. The negative is outside the squared because there's no parentheses around it, plus 6 times 3, because that's what x equals. Do my exponents first. 3 squared, I hope, is 9. Right? Negative 9 plus 18 leaves me with positive 9 plus 1. My y value in this case is 10. There's step 2. I have an x and a y, so what am I going to do with that? I'm going to put it all together to find my vertex. And I get x of 3, y 10. Okay. So the steps are as follows. First, use x equals negative b over 2a to find the axis of symmetry. Step 2, plug in whatever you get for x into your equation. And step 3, whatever you get for x and y, you put as an ordered pair. That is now your vertex. Right? So we are going to skip the exit slip for today. Here is your assignment. The slides will be up on the board. If you do not have a book, go ahead and get started on your homework, and I will be checking both yesterday's assignment and today's assignment tomorrow. Your assignment for today is page 623, 624. It's the second half of yesterday's assignment, so it's a new assignment, same page, same section. So go ahead and get started on your assignment. Here are the first set of problems. Make sure you title your page with your name, and this is assignment number 3, so circle that at the top.